Okay, now let's talk about radioactivity. What is radioactivity? Radioactivity is, or we call it radioactive decay, is actually the disintegration. Radioactive decay. The word decay, it can have two names. Yeah, you can either say decay, or you can also say disintegration. Yeah, radioactive decay or radioactive disintegration. Okay, is the disintegration. Yeah, decay means the same thing as disintegration. Disintegration of an unstable nucleus to a more stable daughter nuclide with the emission of alpha. Okay, so we have alpha, beta, or gamma ray. So pay attention that only the alpha and beta using particle. You see that this alpha and beta, they use particle, but for gamma, maybe I should use another color. Okay, gamma, they use ray. Yeah, you see that? Gamma is different. Gamma is different from alpha and beta. Alpha and beta, they are both particles. But gamma is a ray. Yeah, it's a radiation. Okay. Later I will talk about this alpha, beta, gamma. Okay. So radioactive decay will involve. Yeah. First of all, radioactive decay or radioactivity. What you're trying to achieve? Is you want to change an unstable nucleus. Okay. Just want to highlight it. You want to change an unstable nucleus to a more stable nucleus. This is the objective. Radioactivity or decay is to change an unstable nucleus become stable nucleus. Because that time we talked about this binding energy per nucleon graph against the nucleon number. So like let's say the uranium, you see this uranium, this is unstable, isn't it? Because it has lower binding energy per nucleon. So here is unstable. Okay, so he tend to decay. Yeah, he tend to decay in order so that the graph can go to the left hand side. So from here, decay form a stable nucleus. When you go to the left hand side, you trying to achieve a higher binding energy per nucleon. Okay, you're trying to achieve higher binding energy per nucleon. Here, over here, it has unstable. Because why is it unstable? It is unstable because it is very low binding energy per nucleon. Here, he's trying to decay so that getting a higher binding energy per nucleon. Okay. Unstable because very low binding energy per nucleon. Decay to form a more stable nucleus with higher binding energy per nucleon. Okay, so that's about radiative decay. From unstable, after decay, become more stable. And in this process, this thing will be emitted. It's either alpha or beta particles or gamma ray. They will emit these. For radiative decay, how to know got radiative decay happening? We detect this emission of alpha, beta, or gamma. Okay. So radiative decay is a spontaneous and random process. How to understand what is spontaneous and random? Spontaneous means it is unplanned, cannot be predicted, independent of any physical conditions like pressure, temperature, and chemical changes. Okay, spontaneous means you cannot know when it happened. You cannot know when it happened. You cannot know the exact time when it happened. It just happened by itself. In other words, it happened. Spontaneous means happen by itself. You cannot be predicted, independent of any physical conditions, pressure, temperature. That means we cannot control the reaction. We cannot control the decay. We cannot set what time it will happen. It all happen by itself. We cannot say, oh, we increase the pressure, we increase the temperature, we put the radioactive nucleus under the sun, put it under the sun, or we reduce the temperature, yeah, or we put it under the hot sun, or we heat it up by a hot temperature, boil it, yeah, with high temperature to make the reaction faster. No, it will not increase the rate of decay. Okay, it is independent of temperature. You cannot bury it underground to have a very high pressure in order to make the radiative decay happen faster. Cannot also. Okay, the rate of decay is independent of the temperature and pressure. You cannot also put it inside an acid. Yeah, put it inside the acid, the chemical reactants. Yeah, the acid won't make the reaction faster. Won't change the rate of reaction. Okay, so it's independent of the acid, of alkali, or you cannot. So this reaction you cannot control. You cannot control. It just happened by itself. Understand? That means by spontaneous. It happened by itself. Cannot be predicted. Cannot change the rate. Yeah, we cannot manipulate. Cannot be manipulated. Spontaneous means cannot be manipulated by any way. Maybe you want to manipulate the rate of reaction using acid, using high temperature, high pressure, but it cannot be manipulated. It just happened by itself. Okay, unplanned, cannot be manipulated. That's spontaneous. Yeah, it happened by itself. Cannot know when it happened. Okay, random. Random also means what? Random means, because we talk about radioactive decay, it not just involve about one atom. It has many atoms. Okay, for a sample, let's say we have a sample, okay, of radioactive element. Okay, so it has many atoms. Okay, it has many atoms. All these are radioactive. Let's say all these are radioactive. Okay, I couldn't finish drawing. All these atoms, they are radioactive. Okay, so random means the probability of nucleus decaying at any given instant is the same for all the nuclei in the sample. This is the sample. This is the sample of all nuclei, all radioactive nuclei. All these nuclei are radioactive. But the probability for any nucleus to be decayed at any time is the same. That means, if let's say I say the first atom has 20% chance to decay, so this atom also has 20% chance. In fact, the probability is the same for all nucleus. So it's same, 20%. The first atom has 20%. The second one also has 20% probability to decay. So the rest also has the same percentage. All the rest, all 20% probability to decay. All 20% probability to decay. So we cannot know which one will decay. Yeah, maybe how to say maybe how to remove this. Okay. I don't know how to remove the. So okay, never mind. Just remove this whole thing now. So maybe I can say I just use the black color. So we can say random means the probability for all nuclei to decay is the same. Yeah, you won't say, oh, this nuclei, the first one has high probability compared to the last particle to decay. No, all has the same probability. Maybe at first second this will decay, and then we cannot predict which one will decay. Next, we cannot know exact which one will decay. Maybe the next second is this one decay. Maybe the next one is this decay. Maybe then this decay, and then the next second maybe these two decay, and then decay until in the end all decay. Understand or not? So we cannot know which one will decay first. We cannot know. It's random. It's random. We cannot know which one will decay first. Yeah, which one has higher probability to decay first? We cannot know the sequence. Okay, it's random. All right. So radioactive decay is spontaneous and random. Spontaneous means you cannot manipulate, it's just happened by itself, cannot manipulate by changing the temperature, pressure, or acid, or yeah. Random means we can all particles, all nucleus have the same probability to decay. We cannot know exact which one will decay first. We cannot know exact which one will decay first. All have the same probability to decay. Yeah, maybe this particle will decay, and then that particle unexpected will decay also. Yeah. So all are random, spontaneous and random. All right. So for radioactivity, must involve these either three kinds of ray. Yeah. Either one. Three kinds of ray are produced naturally occurring radioactivity. Natural occurring means it is not induced. Yeah, it is not induced, but it happened by itself. Three kinds of rays is alpha, beta, and gamma. Alpha, beta, and gamma. So only the alpha and beta, they are, pay attention, only the alpha and beta, they are particles. But when we talk about gamma, it is a ray instead of a particle. If gamma is a ray, only the alpha and beta, they are particle. Only the gamma is a ray. Okay, so so now let's talk about alpha and beta decay. All right, alpha and beta decay. So what is alpha decay? Alpha decay. What is alpha? Alpha is alpha particle is the helium particle. Helium is He24, and that means for helium it has two proton and two neutron. Okay, that's why the mass number or the nucleons number is 4. 2 plus 2 is 4. So helium particle. Okay, so during this alpha decay, this radioactive decay, alpha is a particle, beta also a particle. Okay, alpha and beta, they are both particle. Only the gamma is a ray. We see that? I specifically write like that. Only the alpha and beta, they are particle. Now look at alpha decay. Alpha decay is a helium. Okay, so this is the one lah. You look at here. I just put element X, 6 proton with 12 mass number. Okay, and 6 proton, the mass number is 12. Okay, so when emit this alpha particle, okay, which is helium, this is the alpha. Yeah, this is the alpha. Okay, this is the alpha, and got energy release. Okay, so remember about the conservation. The mass number must be conserved. The mass number must be conserved. The proton number or atomic number or proton number also must be conserved. What is mean by conserve? Conserve means left hand side and right hand side, when you total up, they are equal. Okay, tally. Like for example, like this one. Okay, so at the left hand side, the mass number is 12. So at the right hand side, when total up, must also equal to 12. So it is 8 plus 4 equal to 12. So yes, this is correct. Mass number is conserved. The proton number, the left hand side is 6 proton. The right hand side is 4 plus 2, also equal to 6. So proton number also conserved. For all the reaction, is like that. For all the reaction, you must always check these two. Check the mass number and the proton number. They must be conserved. They must be conserved both left and right. Understand? They must be conserved both left and right. That means the left and right, when both sides added each other added together, they must tally. The left hand side must tally to the right hand side. Understand? You understand that? Okay, good. Now look at this alpha decay. This is the X, the parent particle. So when it emit the helium, So you don't know what is this daughter. Never mind, you just write the helium there. Okay, and the parent you know is 612. So if this helium is 24, what do you think is the daughter? Is the way. Yeah, we always write the helium first, then only we predict what is the daughter. Understand? So if this is 6, look at the proton number first. If the proton number at the left hand side is 6, so helium already take out 2. So the Y, the daughter, must only have 4. You understand? Because it's 4 plus 2 equal to 6. Okay. 4 plus 2 equal to 6. Okay, 4 plus 2 equal to 6. And then how about the mass number? Mass number at the left hand side has 12, and then the helium already take out 4. So what do you think will be the Y? The Y should have only 8. Should have only 8 because 8 plus 4 equal to 12. You understand that? That is how we predict the daughter particle. Daughter particle, and we know the proton number is 4, the nucleon number is 8. The left hand side and right hand side must balance. Must tally. Okay, must tally the mass number, tally the proton number. I think this is very easy, you can understand also. Okay. So one thing is you look at here. This element has changed. This alpha particle changed the element because you see the element, the proton number change. Yeah, the proton number changed from 6 to 4. So this daughter particle is a different element compared to the parent. Do you remember about this element? How to determine an element? Okay. Same element must have the same proton number, isn't it? Same element must have the same proton number, or we say same atomic number. Same atomic number. So proton number is the Z lah. They must have the same Z. If the proton changes, if the proton number changes, then the element changes. You understand or not? But if you look at the what if different mass number? What if different mass number? Different mass number, same proton number. If you have another thing we call, if we have same proton number Z, okay, same proton number Z, but you have different, this one you must know, different mass number, which is the A. Same proton number but different mass number. For example, I have carbon 612, I also have carbon 614, I also have carbon 13. So okay, are they the same element? Yes, because they still have the same proton number. Do you see that? They still have, all of them are still same element. This is the they still have the same proton. Same proton means they are still same element. But talking about mass number, they have different mass number because the number of neutron is different. Number of neutron is different. This one has how many neutron? This one has 8 neutron. This one only has 6 neutron. This one has 7 neutron. But the proton is the same. 6 proton, 6 proton, 6 proton. So still same element. But different mass number means these are isotopes. These are isotopes. But they are still same element. You understand? Okay. So when talking about element, we look at the proton number only. We look at proton number. We don't look at the mass number. Okay. Even the mass number changes, they are still same element if they have same proton number. Okay, they are just isotopes, okay, with different mass number. Okay, but they are still same element. Okay, now look at this this alpha decay. So this alpha decay, will it change the parent into a different element when it emit the alpha particle? Of course, because you remove the helium, you actually remove 2 proton. You change the proton number. You change the proton number from 6 to 4. So alpha decay will involve change of element. It will change element between parent and daughter. It will change element, okay, because got proton changes. Because proton changes. Alright? This is very important. It will change element because it change the proton changes. So in short, alpha particle is a helium particle, okay, and it changes the element from. That's why I cannot write this one as X. You cannot write this one as X. No, you must change the alphabet. I change from X to Y, means the element has changes because there is a change of proton number. Okay. Now how about beta decay? Beta decay, will it change the element? Will it change the element? Of course, because you see here also the proton number you have number is not zero. It's not zero. So this one also will change the element. We will talk about beta decay later on. Okay, see you in the next video.